Hi everybody, I'm the greatest living inventor, and today we are doing my invention, external dynamo. So let me write it down. External I'll change a marker because this one is tired. External dynamo. Okay, so just I'll take off my shirt. Okay. Generating a magnetic field for Mars using an orbital ring made of metallic asteroids which are driven like clay pigeon shooting with a laser instead of a shotgun. Okay, so you will understand it eventually. It's long, so we'll just read it through, and I'll explain when it's needed. Okay, external dynamo. But the main purpose is the only purpose is to make a magnetic field for Mars. Magnetic field for Mars. Okay, the planet Mars. Okay, the problem of blocking solar radiation is important for colonizing Mars. We will solve it with concepts familiar to anyone who ever rode a bicycle. Dynamo, which contains magnets that rotate by the rotating bicycle wheel and so produces electricity. We will do the opposite. Move electrons in the metal to create a magnet. Okay, you know that electricity and magnetism are both two sides of the same coin, so you can make one with the other. For example, inside Earth, the liquid metal that is moving is generating our magnetic field. So we will see how to move metal, which is in the asteroids, to produce a magnetic field for planet Mars. Chain, you will see further down the road that the asteroids we build, okay, it's another thing you know from bicycle. Dynamo is one and chain is another. You will see further down the road that the asteroids we build the dynamo from should be connected to each other like a bicycle chain in which you can replace broken links. Inside the Earth, we have an internal dynamo made from liquid iron. On Mars, we don't have that, so we need to move some other conducting mass to create a protective magnetic field. My plan is that we will build a ring made of asteroids that will encircle Mars and rotate in the plane of the ring around it like a giant wheel. Okay, so basically, if we have Mars, and okay, the red planet, and we have a chain of asteroids, and this chain is rotating, okay, like in some direction, the same direction all the time, around Mars, like this. Like a giant wheel. If my understanding about the shape of the magnetic field is correct, it will protect at least all the volume right below the ring and possibly half the planet. For the shape of a magnetic field of a ring electromagnet, an electromagnet that is shaped like a ring, see the following video, Magnetic Field of a Coil by Michael Mellock. Okay, there's a YouTube video, Magnetic Field of a Coil. By Michael Mellock. Okay, so he shows that he has he makes a plastic piece that like a plate that has embedded inside it a ring, a metal ring, like he has this plastic plane that has inside it, he puts two holes, and he puts here a metal windings like this all around, like maybe 20 times like this, and then he puts a wire electricity through the coil. This is the coil, and what he gets, okay, this you should imagine that this is a plane, okay, it's like this is a plane, like towards you and towards the inside of the whiteboard. And what he gets is he puts iron filings, and then he puts a battery, and so this becomes electromagnet, and he gets like the iron filings makes circles, and bigger circles, and bigger circles, okay, and also in the other side it makes small circles and bigger circles and bigger circles. So the iron filings look, and all the circles that don't close on the plastic but are present, they are closed outside of the plastic. So this is the, if we take the plate and try to understand what happened. So the field looks like this. Okay, circles. So we have circles here and going in from here, and they close the circles from the outside. So there are circles, bigger circles, also in this side. And okay, so it's like, it's the same like the Earth is, the Earth has a magnetic field just like this one. Okay, the Earth, if you take a ball and put it here, it will be the Earth. Okay, it has a magnetic field that surrounds it, just the same, in the same way. Okay, and it's made from electricity here, so we make it the same, but without the battery. We just move the electrons inside the metal ourselves. We move the metal itself, the entire asteroids. Okay, so if the idea of surrounding a planet with a ring seems far-fetched to you, I found, after thinking about this independently, that I was beaten to it by no other than Nikola Tesla, the greatest engineer of all time. The following excerpt is from Orbital ring in Wikipedia. Okay, so you can see it in what I'm reading now. It's in Wikipedia under the entry Orbital ring. In the 1870s, Nikola Tesla, while recovering from malaria, conceived a number of inventions, including a ring around the equator of Earth, although it did not include detailed calculations, as recounted in his autobiography, My Inventions, from 1919. Another one of my projects was to construct a ring around the equator, which would, of course, float freely and could be arrested in its spinning motion by reactionary forces, thus enabling travel at a rate of about 1,000 miles an hour, impractical by rail. The reader will smile. The plan was difficult of execution, I will admit, but he's talking about in 1870s. Okay, so we are like 150 years afterwards. I will admit it, but not nearly so bad as that of a well-known New York professor who wanted to pump the air from the torrid, it means dry and hot, to the temperate zones, entirely forgetful of the fact that the Lord had provided a gigantic machine for this very purpose. Okay, which I guess is the wind. Okay. Also, others considered it seriously afterwards, including a few possible uses, not including mine. See Wikipedia. Also notice that Mars is about half the size of Earth, and these orbital rings all talked about Earth. About 8% of every 100, okay, I'm sorry, 8%, which means 8 out of every 100 of the asteroids are M-type, okay, M-type asteroids. M means metal, and they are made of iron and nickel, which are both ferromagnetic. These asteroids can be found in the asteroid belt between Mars and Jupiter, in the middle region of the belt. So together they will be the conducting mass that is moving. How do we build the ring? Okay, so now I'll erase this. What's the time? Like almost 15 minutes, so I need to hurry. Okay, I'll drink something, sorry. Okay. So we continue. How do we build the ring? How do we build the ring that you've seen around Mars, okay? The ring made of M-type metal asteroids. Okay. So, sorry, option 1. Easy to build, hard to rotate. At first, we drag the first asteroid to the Lagrangian point between Mars and the Sun. What are Lagrangian points? They are parking places in space. Thanks to Elizabeth Howell from space.com for this great explanation. Okay, so this explanation of parking places in space is by Elizabeth Howell from space.com. So thanks, Elizabeth. Then we add another asteroid and another, and each time they stick together like magnetic building blocks for toddlers, because of their gravity when they are very close to each other. After each addition, we drag the whole ring so that its center of mass is in the Lagrangian point, and the ring plane is on the plane that is orthogonal, which means perpendicular, to the line between Mars and the Sun. In simpler words, if an astronaut on Mars is looking towards the Sun, from her angle, towards the Sun, if we are on Mars, if an astronaut is on Mars and is looking towards the Sun, okay, this is Mars. And then an astronaut is standing here. And she's looking towards the Sun. Then if you take the plane here, that is perpendicular to this line, okay, so we are building the ring on this line. So it's like this is an imaginary plane, but the asteroids that we put in there are not imaginary, they are on this plane around this line. So they are, if it cuts here, then the asteroids will be here, and here, and here, and here, and here, okay? And each time we make it bigger, but on this plane, on the same plane. We bring them from far away from the asteroid plane. It's not that far away. The asteroid plane, the asteroid belt is between Mars and Jupiter. So we build, so we take them from the asteroid belt and drag them here with the spaceships or space drones. Okay. So in simpler words, if an astronaut on Mars is looking towards the Sun, from her angle, she will see a circle of asteroids. Okay, if she looks up, she sees a circle of asteroids. After the ring of asteroids forms a circle that can enclose around Mars its future atmosphere, around Mars and its future atmosphere, we need to rotate the whole thing and gradually lower it towards Mars after it's rotating. If we lower the ring towards Mars before it's rotating, the asteroids will just fall onto Mars, which renders them useless, plus they might kill our astronauts on the ground. Okay, now option 2. Option 2. Hard to build, easy to rotate. Hard to build, easy to rotate. Okay, at first we drag the first asteroid close to Mars and then give it a push in the right direction so it enters a satellite orbit around Mars and a closed cycle. Okay, we push the asteroid so it starts being a satellite. In a closed cycle. Then we add another asteroid, we bring another one and push it, and another, and each time we make sure they are rotating with a similar speed as possible, with as similar speed as possible, and in the same direction and altitude. Over time, with enough asteroids, they will stick to each other while still rotating and form a closed loop that is rotating. Of course, the exact push that needs to be given is easy to say but very hard to do. Okay, it's hard to build. Also, as the ring becomes more populated, how do you squeeze in the new asteroid without the existing ones hitting it? Okay, option 3. Moderately difficult to build, moderately difficult to rotate. Okay, so I'll write it here just so I have room. Moderately difficult to build and moderately difficult to rotate. That's option 3. This is a combination of the two previous methods. We start like option 1 with a static asteroid into the Lagrangian point. Then, when we bring the next asteroid, we rotate slowly the developing ring. We start to rotate this. And bring it a little closer to Mars. So we bring the whole plane closer to Mars, all the ring so far closer to Mars, all the ring that we built so far. With each added asteroid, we add a little more speed to the developing ring and bring the ring a little bit closer still to Mars. Okay, so on the next one we make I don't know if it came out clear, but we give it more speed and bring it closer to Mars each time, the whole ring that we built so far. With each added asteroid, we add a little more speed to the developing ring and bring the ring a little bit closer still to Mars. Since everything is gradual, it should pose less challenge compared to rotating a complete static ring and compared to pushing an asteroid to an exact empty slot in a fast rotating ring. How do we keep the ring rotating? Okay, so our next problem . How do we keep the ring rotating? Okay, we have Mars, we have a ring already around it, but how do we keep it rotating all the time? Suppose that we succeeded in building and rotating the ring. In parentheses, I recommend option 3, the moderately easy to build, moderately easy to rotate. Close parentheses. When the ring is generating a magnetic field, the magnetic field itself will exert force in the opposite direction to the ring's rotation. In other words, the field will try to slow down and stop the ring, because otherwise we have just built a perpetual motion machine, which is impossible. So we need to supply energy for the ring to keep rotating. Of course, this should be solar powered. Okay, because we don't have another option there. Okay. Sorry. We need to make an engine to push that pushes or pulls an asteroid in space and uses the sun's light. I suggest we build it using electromagnets. Asteroid propulsion with electromagnetic coil gun using solar energy. Okay, here I have a link to YouTube. I'll put it in the description. It's basically by gun makers Holland and Holland, and it's pigeon shooting with a shotgun. Okay, pigeon shooting. I know it sounds like totally not related, but it's related. Shooting with a shotgun. Okay, so of course it's a metaphor. We will use this idea but do something else with it. So there's a video, I'll put it in the description, by Holland and Holland. My first idea was to make a coil gun where the electricity will come from solar energy. Okay, coil gun, I think we talked about it in another invention. Coil gun, if you're not sure what it is, look at in Wikipedia. It's like a magnetic rifle, magnetic gun. Sorry. So my first idea was to make a coil gun where the electricity will come from solar energy. Each time we dig a small piece like a pebble from the asteroid using lasers. Remember, the material of the asteroid is ferromagnetic. We magnetize that little piece with a strong electromagnet and shoot it into space with an electromagnetic coil gun. But then I got worried that the electromagnets, although instantaneous and random, will interfere with the magnetic field of the whole ring and possibly collapse the ring. So instead, I think we should do something mechanical that works on electricity, like the same trap machine that projects the clay target in the video. Okay, the people that shoot they don't shoot ducks anymore, they shoot a plate of clay, but the thing that shoots the plate of clay into the air and throws it far away is called the trap machine. So trap. So this trap machine, we need something like this, but activated on like between a coil gun and the trap. A solar coil gun. Okay, because we are using solar power to make electricity, and with the electricity we make a magnet and make a coil gun, and we put inside something that it shoots, so it's like a trap of pigeon shooting. Okay. So you got the idea. For every action there is an opposite reaction, Newton's third law, which sends the asteroid a little in the opposite direction. So if there is a trap machine, something that throws, like if I throw a ball to there, I'm pushed back. So this is Newton's law, third law. Of course, this method of shooting stones in random directions, is not very safe. And also, if it hits the neighbor asteroids, it will move it in the opposite direction. And also might hit and ruin the engines on that neighbor. The neighbor effect can be mitigated by shooting in two oblique directions that cancel each other. The danger in shooting can be mitigated by creating the ring before we colonize Mars, making sure the ring is not shooting in the direction of Earth or the ISS, the International Space Station, and shielding the few things we do have on Mars in that stage. Since the solar engine unit is effectively digging slowly into the asteroid, it should be mobile between launches, between stone throwings, this is launches, and to relocate itself on the asteroid to another location each time. Okay, so if we have one of the asteroids, okay, and we have this small unit, like I'm drawing it with the wheels, although it's not with wheels, but so we understand it's a robot. Okay, let's draw it like a spider. Okay, so it has okay, so this is the unit and it walks on the asteroid, and like once it digs here, okay, it makes it has a laser and it digs something here with the sunlight. Okay, it uses the sunlight to make electricity and to dig something here, and then for example, if the next asteroid is here and also has a robot, but never mind, then it goes towards that asteroid and shoots it okay, the shooting can be, it doesn't hit the asteroid, okay, it's just this is the direction that we want. We want them all to be pushed in the same direction. Okay, so this looks like I shot the asteroid, which is bad. Okay, I'm shooting towards the place. If I want the asteroid to go like this, then I'm shooting towards here. Okay, so at first stage the robot is digging or carving, and in the second stage it shoots. Okay. Since the solar engine unit is effectively digging slowly into the asteroid, it should be mobile between launches, stones throwing, and to relocate itself on the asteroid to another location each time. If it will dig here all the time, then we will have a big hole here, which is not good. We want it to take material from everywhere, but shoot always from this spot. So it digs and goes to here and shoots. It digs and goes to here and shoots. Okay? If we see the ideal asteroid as totally round like a ball, then this digging should be on the largest bump, in parentheses protrusion or bulge, of the asteroid. So here, if here there is a bump, okay, so here it will dig. Then the largest bump will be somewhere else and it will dig there. Okay, so keeping the asteroid more or less round. After traveling on the asteroid and before each throw, the unit needs to anchor itself to the asteroid. This can be achieved with electromagnets, in parentheses, if the throw is mechanical, like clay pigeon's trap machine, close parentheses, that momentarily glue the unit to the asteroid. Or the unit can dig itself into the ground with some mechanical clutches. The ideal solution is to separate the digging location, the largest bump, from the shooting location, the exact place we want to push the asteroid from. This requires more trips from the unit, but doesn't require any anchoring, because the recoil from the shooting will glue the unit to the asteroid. Okay, the unit is pushing and it sticks to the asteroid from the recoil. As for the way of moving upon the asteroid, I think robotic legs are best, because wheels rely on the ground being flat and even, which is not given here. Another disadvantage of this system of propulsion is that it requires minimum size of asteroid, because we are wearing the asteroid out and wasting it little by little. After we wasted an asteroid in the ring over a certain limit, we need to replace it by bringing another asteroid, which forces us to option 2. Remember from before, option 2, because the ring is already spinning. A possible solution to the stray shooting of rocks, okay, this is what I said, that we don't want rocks hitting everything, small pebbles, but still, it's shooting them, it's like a gun. So we don't want this shooting hitting anyone. So a possible solution to the stray shooting of rocks is to incinerate each rock right after we shoot it with another automatic laser from the asteroid, like clay pigeon shooting. Okay, so we have the robot is shooting, but is also, after there is here there is the pebble. Okay, the pebble is was shot from the robot, and then the robot is using the same laser that it had here to shoot on the pebble and to vaporize it. Okay, so the pebble is gone. The system of the excavator, shooter, evaporator, okay, this thing, the robot. Excavator, shooter, okay, and step 3, evaporator. The system of the the system of the excavator, shooter, evaporator needs to work from a battery, because sometimes the system will be in the shade of the asteroid or Mars or both. The battery will be charged by solar power when there is sunlight. Another concern is that the power of the magnetic field will disassemble the ring. Electromagnetic force is much stronger than gravity. To prevent this, I suggest that after the ring is built, we attach the asteroids to each other to form a rigid structure. This should be like a huge chain, because we need to make bypasses, in parentheses, where we replace an asteroid or link, a link in the chain, on the chain, close parentheses. The material for the chain links between the asteroids can be excavated from smaller or otherwise unfit asteroids. Commercial mining on asteroids was seriously discussed for profit in the past. Okay, now it's another problem that we have, which is precession. Okay, I'm not explaining what precession is because I don't have time, but you can write precession in Wikipedia, and look it up. It happens in when you have a gyroscope. It happens when you have this toy top, like Jews have in Hanukkah. It happens when the wheels in the car are not aligned, misbalanced. It happens, and then the steering wheel is shaking. It happens in a lot of places, even in your phone, in your mobile phone, when it's on vibration. They do this with the rotating something that is not aligned, and then you have precession. So I'm not explaining what it is now, but precession is basically when you have, let's say, our ring, and it rotates, let's say it rotates like this, okay, on this page, and while it's rotating like this, we are trying to rotate the whole plane, like do something like this. Then it doesn't like it when we precession is when we do this, and nature doesn't like it. Okay, it tries to keep it in the same way that it was. If we push something that is doing this, then it will keep doing this in the same alignment. Okay, so you should look it up in Wikipedia. Okay, precession. Another problem is the precession of the ring when it rotates. Here you see, so this is like a video that I will put in the description. Here you see ESA, European Space Agency. Astronaut Tim Peake, ESA, astronaut Tim Peake. It's a video about precession. It's nice, showing a toy gyroscope in the International Space Station. The ISS itself, the International Space Station, also works with real smaller gyroscopes to know its own angle. Okay, so I will put the link in the description. So this is about gyroscope. So again, I'm not explaining what it is. You should see it in the video. I think the precession will stabilize the ring like a gyroscope or a top or a toy top that you rotate. But I don't know enough physics to be sure of that. So let's assume the ring does precess. This causes a problem because of the uneven gravity of Mars as compared to Earth. Mars is not round enough. It has Olympus Mons, which we talked about in another invention. This means that the ring needs to be of larger diameter so as to be further from the planet and to take into account a magnetic field that is shifting very often. I don't know how to calculate how fast the precession movement can get, but if it is fast, it can be a problem for spaceships and to and from Mars. Of course, we can compensate with the above mentioned solar engines and the robots and avoid the precession altogether, but this will wear out one side of the asteroids constantly, so it's not a good idea. One option to fix this is to give the asteroids freedom of movement. In parentheses, the links between the asteroids need to have a free axis. Okay, this is like the chain that you have in badges of not like the chains that soldiers have in the army that if they died, it stays and you can read who it was and recognize them. So it's, I don't know how it's called, but this kind of chain. Okay, it looks like balls and thin connections, and it's free moving. And also you can see this kind of chain in what's called chain fountain. Okay, chain fountain. Which is also called self-siphoning beads. Which is also called mold effect, after Steve Mold, which found out about it. Okay, so you should also look it up in Wikipedia, and also there are very cool videos. So it's like you see there that I'm not talking about the effect so much as about how a free moving chain of this kind is moving. So it's moving, the beads are moving. If there is, like for example here, a dent, then it will, if new beads are coming, they will follow more or less the same shape. Okay, it keeps on the same shape if it's flexible. So this is what I'm hoping to be doing, that will happen in the asteroid chain if it's flexible. One option to fix this is to give the asteroids freedom of movement. The links between the asteroids need to have a free axis, and the solar engines units, the robots, need to be mobile on the asteroids, which they are anyway, we want them to be mobile. Conclusion. As you can see, every solution brings with it another problem, but I think the general idea is solid enough for professionals to consider, especially given the enormous benefit of allowing us to terraform Mars and, in essence, give humanity a plan B in case there is an extinction on Earth. Okay, so I hope it was clear, and I'll see you in my next invention. So thank you very much. Bye-bye.